All right, as you can see by the screen, we do have a working Galaga at this point. This is the customer CPU board and my video board. I was just doing some looking and thinking on this thing. Took a step back and took a break from it, kind of refocused the brain. Right now, the only issue left on the CPU board is, let me turn the volume up. You can hear the hum coming from it. So all sounds work. We just have that buzzing. Now, we did recap here our electrolytics. So what I do want to do yet is change out these two tantalums here. And we're going to check the pre-op amp over here. It's a 324. They are notorious for failing, but we're going to test that and the caps associated for this to see if our buzz is coming from here. But I wanted to power it up and just make sure game is still working. This board is good. I wanted to show you one thing that's been making me think here. So I'm going to pause the camera here. Let me power off the game, and I'm going to connect the customer's video board here, and I will show you what we're getting at that point. I think, in hindsight, I mean, we had, on the CPU here, we had two different trace issues. I think we're going to have one more on the customer's board. I pulled out all the ICs. I forgot I did that last night. Just staged everything. What I want to do, when the customer's board's attached to this, the game will not boot fully, which makes me think somewhere on here we have a data lines crossed, touching each other, short data or address line issue. So at this point, nothing looks bad on the bottom of the board. Everything looks good. What I can see on the top looks good. No shorts or anything like that. We're still getting the bars, but it's not booting. So what I want to do is pull all these sockets back out and reinspect the board on the top here to see if we have any trace damage. I think we have a bridge or something here, as I said, in the data or possibly the address lines. So that is my next step. So let me get the desoldering iron fired up, get these out of here, and we'll take a close look at the board. Well, I pulled all the sockets out we put in, ohmed out all the traces. Our EPROMs and customs here, all were fine. PROMs were good as well. When I first tested this, after we had the sockets all changed and everything, the screen gave us those lines and everything, and I thought it was a RAM error. Well, technically it is a RAM error. It's just not what I was thinking. What I found after pulling all the things, the sockets that gave us the problems here I marked. Now the rest I repopulated, but the two here, these are the 2114 game RAMs. And 3J and 3K both have damaged traces. Now, the bad part is this trace here runs up through, that's one of the address lines, address 3 or 4. I'm not sure which one on it. I'd have to look at the pinout on a 2114. But that is severed from the 3 down here. Right here, that pad. Let me get you down here a little closer. There we go. Right here, you can see that is severed right here. So they're no longer, that address line is no longer chained together. So that is on our 3J. Our 3K, this pad is severed here. Now, I did look at our 16 pins, so our 20 pin sockets, and there is no, again, no traces or anything on there. I have no idea how I ripped these out, taking them out. They didn't fight me. The sockets came out with no issues, but those two are severed. So what I'm going to do, I'm going to scrape these back here, solder in a new trace coming over and going down through. Same with here. That will join all these back together when the socket's put in the solder. That'll reconnect all that. So let me get that done, and we'll show you that repair before I put the sockets in, and then we'll get the sockets in and see if we have a booting game at this point. All right, I got the trace repair done. I'm going to ohm this out before putting any coating or anything like that on it. So, let's see. I'm going to follow that down. That one is now good. And follow this down. Let me check here. I think it's just because I don't have these soldered in yet. I should go up to this pin. Yeah, I think that is just because that is not soldered yet. Yeah, there we go. Once the solder fills that that through hole is still here, so that's going to fill that in. So the traces are good. So let me coat these here, just so they're covered traces at this point. So let me get that done, and I'm going to solder those sockets back in. Then we'll populate everything and try it out. All right, board is back together. Everything's back the way it was. Instead of putting the new RAM that I put back in here, I did put the customer's RAM back in. Just want to see what happens with it. The issue was the sockets themselves. Now, we did have the white lines going down. We still may have those. That's going to be our video RAM here. So I'm hoping now that this is those address lines are corrected. We're going to have a booting game. So let me get everything set up here. All right. Monitor fired up. Power, ground cables. Everything's in the correct direction. And we will see now if we have a booting set of boards. Here we go. We have no different. That makes no sense. That is exactly the same as we had. We're not even booting the game. And I checked all of our traces. I have owned everything out here. So it's not a trace issue. So we're going to have, let's see. Yeah, it's an address or data bus issue here. So, hate to say it, but let me get the Fluke out and plug into this thing, and we're gonna do some tests with that and see what that shows us. So let me get that set up, and we'll be right back. All right, well, I got the Fluke hooked up. Do not laugh and bust me about my connector here. I broke the 40 pin. My Fluke cable lost one of the pins here on it. I tried to do a quick solder on it. It's just need some more time than I have for it, so I threw together a spare one real quick and got it on there. So I will fix that whenever I get a chance. Now, I do have the Fluke hooked up. Let's bring that up so you can see. Get that up on the screen. All right, so just went through the setups on that. Had to change a few things. We'll try a bus test here real quick. Power the board up. And we'll see what it says. I mean, as I said, I think we have a memory issue or a decoding issue with it. And let's do a bus test. Do I have a connector on? That is tight. Power is on. Let's try that again. There we go. All right, bus test okay. All right, so let's see. The Galaga, let me bring up my notes on this. All right, so let's try a ROM test just to make sure everything's communicating okay. I think it is because we passed our bus test, but let's just find out. We'll test the first run. Maybe we will. Let's try that again. There we go. And H7FF. Oh, what's the signature on that one? D18D. All right. Oop, too many D's. That's not going to like that. Let's try that again. Helps if I could type on a keyboard a little bit. Like I said, I know we got a memory issue just because of the lines we had on the screen when it was booting, but that is one of our video RAMs. That will solve after we get the game going. And the only thing left on the CPU board to fix is that hum that was coming from the sound. Again, that will take care of once we get the game up and booting. We should about be done. Oh, I know why it's failing. Or not failing, I typed the wrong number. Let's try that again here. We can do a ROM test. Let's get the right address range this time. It's 0FFF. As I said, this thing definitely has me off my game. D18 Delta. Now let's try it. I bet it works a little better this time. This one has me so frustrated at this point. I'm done with the coffee and I'm trying a Guinness. All right, ROM tested okay, so we're good on the ROM. Let's just go to a RAM test now. This is where I think we're going to run into issues. Is that I ohmed out everything I could think of. All right, RAM is 8,000 to 87FF. Oh, no, not one of those days. Try that one more time with the correct numbers. They work better when you give it the right address range. 8,000, not 80. 87FF. My keyboard's sticking a little bit. Now, let's see if it works this time. That looks much better. Hopefully this is going to pinpoint the error on this. As I said, I ohmed out everything. I had continuity between the RAMs, the customs. Everything seemed to be working that way. There we go. All right, so we have a decode error. Address 8,000, bit 5. All right, so bit 5 is our problem child. Let me try one more at a different address just to see if that's the same, see if we get the same bit error. Oh, let's try another set of RAM here. That was for that RAM. Let's try one of these pairs. So let's go with 9,000 to 9BFF. We'll try, as I said, the first test for the address ranges we were working with, whether it's for the 2016 RAM here. Now, I'm not sure what pair it's going to check here, but it's one of these. These work in pairs, so we'll see if we get the same error. If it does, that kind of points it back to the input side in the decoding area. Yep, same thing. Address 9000 this time, decode error, bit 5. So the same bit. All right, so we're done with the Fluke. Let's bring up the schematics, and I'm going to start looking through and see what decoders here we're going to be using to get through. I know it's going through the 04. I know we're using the 138 here as well. So let's get the schematic brought up, and we will go from there. All right, got the schematics up on it. I'm doing some poking around with the logic probe and finally hooked a scope up just to take a look at some of the signals and stuff we have. And did find another problem here. If we look on the schematics here, bit 5 comes in through a pull-up resistor and enters into the address bus here. If we follow this up, that is just address, that's bit 0 through 3 coming down into here. So first stop they make is the 04 custom here, which I believe this is just a buffer chip. So address 5 comes in on the pin 20 here. The bus also continues over, and it will go up to our 2016 RAM here. And in on 5, pin 3 for him. Also jumps over to our 00 custom, which is on pin 21. Now, I ohmed all these traces out, these two here, and down to here. So all these are good to this point. I looked at everything with the logic probe. We're getting a pulsing and everything on all the lines. But when I checked the output here, where we come out buffered, completely different looking signal when I seen it on the scope. So that made me poke around with the meter. So let me, let's see here. We're going to go into the 04 custom here on pin 20. That's bit 5. As I said, we're coming in on 26 here. So let me get rid of the schematics. We're done with that for a few moments. Let me get the Fluke or the meter out here. Set it for continuity. Now, let me get you down a little closer, make it a little easier to see, hopefully. All right, so pin 26, we're coming in, goes under the board to this via right here. Comes up through and drops down to pin 20 here. So if I take and put one lead here and go to pin 20. So there's 15, 16, 17, 18, 19, and 20. No continuity there at all. Now, if I follow this through on 20 and go through, we have it. So we're losing it right here between on this trace here. So I think I'm gonna pull this out, take the socket out, and I think we're gonna find another damaged trace right here on pin 20 where it connects. So meter is good. So we have everything else but that signal. So let me get the board split apart, get that socket out of them again, and take a good look at. I could run a bodge wire from there to here right now just to test it and stuff, but I'm not going to leave it like that. I hate that. I think it's a crappy looking repair. If I can repair the board, I'd rather repair the board and running wires all over it. So I'm going to pull the socket anyway, just because that's what I'm going to do. So let me get that out, and I'll zoom you back in when we get that. Hi guys, I hope that's not too blurry. This thing doesn't zoom in great close up. But as you can see, pin 20 right here, that trace is missing going up. So there's our problem with bit 5. So let me run a repair up underneath that socket up there and get a new socket put in them, and we'll try it again. All right, got the trace repaired, put a lead down through, tacked it onto the existing trace, ran it down through, got some coating on it. So that is locked in place. I did ohm out the rest just to make sure I don't see anything else. So we're going to get the socket in, and we'll see what happens then. All right, As you can see, we got it all back together again. Got the Fluke up. Bus test pass. So let's do a RAM test again on those addresses. I think that was 8,000 and 87FF. Oh. This one has been, it's been a challenge. Unfortunately, part of it has to be for me lifting pads and traces on it, but yeah, come on, pass the test. If this one goes, we're going to test the RAM here. We'll go down through all of them. All right. Yes. All right. So our bit is no longer hanging. All right. Let's do another one here. Let's just move down the line. As I said, that one tested a RAM here. So let's go into these and check these now. So next address range is 8800 to 8BFF. Might as well check them all since we got everything hooked up. If this works, we'll just run the we'll run the unit here with it from the Fluke and see what happens. I would hope we'd have something different on the screen. Hopefully a game that plays. All right, good. That one's okay. And next address is 9,000. Excuse me, 93FF. Now, if this works, I think we got a video RAM problem yet. We're going to have to solve that. Shouldn't be as, yes, good. Another one. Should not be a pain like this one was. And the sound issue, that should be fairly easy as well. All right, last one is 9800 to 9BFF. I've not, the Fluke cannot see these video RAMs, unfortunately, so there's no way to test those through it. But this should, if this one works, we should have everything the CPU needs to get us up to a booting game. All right, good. That memory location is good as well. All right, let's go over here to run UUT. And enter. All right, may need to read, not a big deal. Let's change our input here to VGA. Come on, you can do it. All right, now let's see what we got on, see what we have. Ooh, I hear a note hanging. That looks much better. We do have a stuck sound. Oh, it's trying. Okay, so we're definitely making it farther. We're getting to our RAM. Okay, it's getting the self-test in and we're failing. All right, so we are resetting. So the code's not being executed correctly and our watchdog circuit's kicking in. All right, making progress. Well, sometimes you just got to stop, step back, and look at the little things. What I did here, I was done with the Fluke test on it, so I pulled the pod and everything off. And when I put the Z80 back in, let's get the monitor fired up here. And turn the power on to the game. One thing I notice, no buzzing sound coming from the speaker now. We have sound, and we have a booting game. The only thing I could think of is when I fabricated that temporary adapter here for the Z80, I used a lot of wires and stuff like that on it. I think it just induced enough noise where it could run the tests on the game, but it could not run the game. So, as of right now, everything looks like it's working. As I said, I have the volume turned up pretty good, and I'm not hearing the buzzing sound anymore. Usually, noise issues are going to be the capacitors here for the main amp. Possibly you have a 324 op amp over here that kind of is a preamp for him. And there's some capacitors associated with him. They could cause the issue. I've seen those fail and cause the noise issues and stuff, but that seems to be working. So I'm going to, let me grab the joystick here. I'm going to shut the lights off and let's just start a game. It's in free play, so we don't need to coin up. Sounds all right. We got movement. A little hard to play sideways here, but so we got explosion sounds and everything. Something is different though. What are we missing here? Hold on. Let me end that game once. I don't see a Starfield. Just when I think we're almost done. No, we have no Starfield at all. Okay. Well, so much for being done. Well, so, let's get the lights back on here. But it's a good sign. We're making progress. Like I said, we're running off the Z80 now instead of the pod. So I think that was our issue with us resetting and everything. So let me take a look at the schematics and look at our custom for the Starfield, and we'll go from there. All right, just took a quick look over the schematics and everything, and our 05 custom that lives here is responsible for a Starfield. I was checking him out. He was pretty much dead, not doing a thing. Check the voltage on him. No 5 volts to him. I don't know if you guys can see this. Let me bring it down here a little bit. One of the new sockets I put in, if you look at pin 24, which is our VCC for this, that pin is it's flattened out down there. So, chalk it up to another stupid mistake. So I'm going to pop him out, put a new socket in, and we'll try from there. All right. I got the new socket in on that. Here is the old one. You can see that pin was damaged. So that's been replaced. As you can see, we do have a Starfield. Let me turn the light off, just make it a little more visible. So what I'm going to do right now is the game's been running now for about an hour. So I'm going to play a game. Let's see how it works. I'm not going to do a long game on this, just enough to play here a little bit, test everything else. The graphics look good, sounds good, and it is playing correctly. So we'll finish a game off here. I'm going to let the game set. My fire button on the joystick is not working the greatest. Capture me. If everything works good here, we're just gonna let the game set. I'm gonna give this one a good 12 to 24 hour burn in on it. Yeah, my fire button on my joystick's not working the greatest. Alright, I'm just gonna let it die off here. Game's working good. I'm happy with what we have. It's not as fun when your fire button doesn't work as good. Alright. Like I said, we're gonna let that burn in for a while. Going back through, just going through some of my notes, the sound is working because I think when I was working on the trace issues here, I changed out the tantalum caps here, and I think that was part of our issue with the sound. They had this filter cap added on here to take care of the problem before, so that is what that was added for. This is no longer needed. Trash can with that. The only other thing I could think of is we had the 51 chip here that had the broken leg on him. This is the one I repaired that was in the game originally. Had to cut away some of the housing here, get enough metal exposed. I was able to solder a leg on. It held pretty good. This chip, unfortunately, though, is bad. It does not work in the game. So in the end, we needed basic maintenance, new sockets, capacitors. Chips needed cleaned. It did take a 138 here. That handles the upper bits for the decoding. That was, didn't like the output on him. It did not look clean, so he got a new one. Other than that, I think that was it, other than the trace issues we had with the game. Ribbon cable is good. It does have the newer resistor packs on it, so nothing to do with those. So the only thing left to do now is just give it the burn-in test. And if it's all good, put the standoffs in it and ship it out. This one's, as I said, this one was trying. It taxed my patience. And I know it was frustrating for me, let's just say that. I think after this repair, I'm going to step back and knock out a couple centipedes or something quick and easy I can hammer out and without thinking too much on, kind of reboot the brain. But thank you guys for sticking out through this one, and thanks for watching.